Hello my friend, happy to see you here. Today we have great, quick and relaxing algebra question. We have system of two equations, a sum a plus b equal to 10 and a product a times b equal to 15. We need to solve this question for a and b. So if you have your solution, your answer, your approach, you can also write your solution in the comments below and then we will check your answer. So it will be really interesting and this is a great way to practice algebra with me. Okay, so this is our system of two equations and what is the main idea? First of all, let's express b or a from the first equation. This is up to you. I prefer expressing, for example, b in this case. So b equal to 10 minus a. We have 10 minus a. And right now, the main idea is to plug in, instead of this b to the second equation, is to plug in this 10 minus a. So let's do this. Let's practice it. So we have a times 10 minus a, 10 minus a equal to 15. And right now let's simplify it. We have only one variable, we don't have b, so we have only a. This is really great for us because it looks like this is a quadratic equation. So we have 10a minus a square and equal to 15. Okay, right now let's change an order real quick. So as a result, what do I mean change an order? This is a classic quadratic equation, but we prefer a classic order. We prefer a square on the first position, so we have minus a square on the first position. On the second position, 10a, so plus 10a. And we have minus 15 from the left, from the right side, so minus 15 equal to 0. And we have a classic order of coefficients, but we don't have a classic order of signs because basically we don't like this negative sign in the beginning. So that's why my quick recommendation and a quick tip for everyone is to multiply both sides by minus 1. And then we have a classic order of signs. So we have a square, so we don't have this negative sign because we don't like it. And here we have the next thing plus minus 10a, minus 10a. And plus 15. So we have a classic quadratic equation, a square minus 10a plus 15. Right now let's solve it. We don't have b, we have only a, so it looks like right here we have two roots, but we'll see, yeah? So as a result, we write our coefficients right here real quick. So we have a equal to 1, b equal to minus 10, and c equal to 15. Okay, we have three coefficients, and let's solve, for example, for discriminant. Okay, I don't like to solve for a first and a second instantly. I like to simplify our to solve for discriminant, and then I'll plug in that discriminant into all known formula. So our discriminant equal to b square minus 4ac. What do we have? B square, so minus 10 square minus 4 times 1 and times c times 15. Okay, so let's simplify it. So minus 10 square equal to 100. So 100 minus 4 times 15 equal to 60. So our discriminant equal to 40. It means that our discriminant is greater than 0. So it implies that right here we have two real number roots because our discriminant is positive. It's also really great. Right now let's solve it for a first and a second. Okay, so let's do it. Right now let's plug in everything because right now we write this all known formula minus b plus minus square root of discriminant and all over to a. Okay, so let's plug in everything right here. So minus b equal to minus 10, so we have two negative signs, minus 10, plus minus square root of discriminant, square root of 40, and all over to a 2 times 1. Okay, so let's simplify it. So we have minus 10, this is our 10, plus minus. What about 40? 40, this is not a table case, but we can express this in a different way. How can we express this 40? I hope you understand that the best way to express this 40 is 4 times 10 and all over 2. Why do I express as 4 times 10, not like 5 times 8? Because 4 square root of 4 equal to 2, so we can simplify a little bit this expression. But how can we do this? Of course, we can do this according to a square root property. Square root of a product equal to product of square roots. So we have 10 plus minus. We can split it. Square root of 4 times square root of 10. And we divide it by 2. And right now, square root of 4 equal to 2. So it simplifies this expression a lot. So we have 10 plus minus 2 square root of 10, 10 plus minus 2 square root of 10 over over 2. And in the end, we can simplify this. We can divide our numerator by 2 by parts, or we can factor 2. This is up to you. Of course, we can do this in this way. So 10 over 2, so we can divide these elements by 2, and plus minus 2 square root of 10 over 2. And from here we have 10 half equal to 5. So 5 plus minus, right here we can cancel these two. So 5 plus minus square root of 10. This is our answer, but we have plus minus, so we need to consider these two branches. So we have first branch, a first, let's write with the positive sign. So we have 5 plus square root of 10, for example, and the second one, a second, equal to 5 minus square root of 10. So right now, this is not a solution to this question because this is only our first variable, a first and a second. But don't forget about the beginning, because in the beginning we had b equal to 10 minus a. So our answer is the pair a times a and b. So that's why we need to solve it for b first. We need to solve it for pair a first, b first. So that's why we're going to find b first equal to 10 minus a first. A first is right here. So 10 minus a first. So b first equal to 10 minus a first, 5 plus square root of 10. B first equal to 10 minus 5 minus square root of 10. So 10 minus 5 right here equal to 5. So b first equal to 5 minus square root of 10. We have two symmetrical roots, 5 plus square root of 10 and 5 minus square root of 10. So this is our first pair, a first and b first. Right now, according to the same logic, let's solve it for b second. Because we have a second, we need to solve it for b second. So b second equal to 10 minus a second. So 10 minus a second. So b second equal to 10 minus this one, 5 minus square root of 10. This is our a second. So b second equal to 10 minus 5 and plus square root of 10. Right here, 10 minus 5 equal to 5. So b second equal to 5 plus square root of 10. So this is our b second. So we have two pairs of roots, and let's write it. Let's write it as an answer, and then we will check it. Okay, so our answer to this question. So first of all, a first, b first, 5 plus square root of 10. This is our first, 5 plus square root of 10, and 5 minus square root of 10. And second pair, 5 minus square root of 10 and 5 plus square root of 10. 5 minus square root of 10 and 5 plus square root of 10. Okay, this is our answer, but in the end, let's check it real quick. So we have our system of equations. We have a plus b equal to 10 and ab equal to 15. Okay, this is our system of two equations, and let's check, for example, real quick our addition. But in terms of addition, we don't need to check both of these pairs because we have addition, and a plus b is the same as b plus a. Moreover, we have the same constant and the same signs, but in a different order, like plus minus, minus plus. It doesn't matter if you're talking about addition. We're talking about, if you're talking about like subtraction, it does matter, but in terms of addition, it doesn't matter. So we have addition of a plus b equal to, let's check this one. So 5 plus square root of 10, yeah, and plus 5 minus square root of 10. Okay, so 5 plus square root of 10 plus 5 minus square root of 10. We're going to cancel this square root sign. We have 5 plus 5 equal to 10. So addition works absolutely perfectly. Addition is great. Right now, let's check real quick our multiplication. So a times b. And we, for example, let's check this expression. We don't need to check both of these. Let's check, for example, this one. So a, 5 plus square root of 10 and times 5 minus square root of 10. And I really hope you understand this school formula. When we have x plus y, x minus y. What do we have on the left side? Difference of squares. So x squared minus y squared. So this is the same thing. This is our difference of two squares when we have x squared minus y squared. This is equal to x plus y times x minus y. So we can consider it as a difference of squares because we have exactly that case. So we have 5 squared minus square root of 10 to the power 2. 5 squared equal to 25 minus square root of 10 equal to square root of 10 to the power 2 equal to 10. So 25 minus 10 equal to 15. So exactly the same expression. So we have it right here. So a times b need to be equal to 15, and we have this expression. So this is my solution to this question. I really hope you understand it. I really hope you learned something new, but definitely don't feel bad if you got this wrong. If you need help with any of these classes, I have a lot of questions on my YouTube channel, a lot of different type of question, Olympiad question, entrance examination question, and if you're struggling with it, you can easily watch maybe in other videos. But if you're talking about this question, this is not a hard question. Everything you need is just to pause the video and try to understand it. This is basic, a classic method of substitution, and then a quadratic equation. So everything it depends on quadratic equation, and in the end we check it. So my quick suggestion is to pause the video if you're struggling with it and write the solution on your own, and then check it with my on a screen. Okay, so thank you for your time. Take care of yourself. Have a great day. I want to say thank you for being here, for watching this type of content. It inspires me a lot, and it makes me clear and understandable that maybe it's something I do correct, that because my main goal on YouTube is to make math clear and understandable for everyone. And if you learned something new, I'm really inspired and I'm really happy about it. So wish you all the best in your life. Take care of yourself. Have a great day. See you in the next videos.